Tonight's video is on simplifying rational expressions. By the end of this presentation, you should be able to identify a rational expression and also simplify a rational expression. What is a rational expression? It's really just a fraction. One in which the denominator is not 0, of course, because we cannot divide by 0. So for example, let me give you one. We might have x plus 2 over x plus 6. That's a rational expression as long as x cannot equal 6. Because if it did, we would have a denominator of 0. Okay, in order to simplify a rational expression, you first have to factor each polynomial, the one in the numerator and the one in the denominator. So I notice that the one in the numerator has a common factor of x. So I'm going to take x out of the numerator. That leaves me with x squared minus 3x plus 2. Now I notice that my denominator is a trinomial, and so I need two numbers that multiply to -5 but add to 4. And normally I draw my little x, but this one is an easy one, so I'm just going to go from here. I know I start off with x, and I'm going to do plus 5 and minus 1. Alright, the next thing I'm going to do is I notice this trinomial up here is factorable, so I'm going to factor it, and I'll draw the x this time so we can see it. Remember, I need two things that multiply to whatever the coefficient of the squared term times a constant, which is 2, but those same two numbers have to add to a -3. And those two numbers are a -2 and a -1. So this trinomial is now going to be written as x minus 2 and x minus 1 all over a denominator of x plus 5 times the quantity x minus 1. And now I've got everything factored. I cannot factor anymore. But what I do notice is that I have x minus 1 and x minus 1. One in the numerator, one in the denominator. And I know that whatever it is, a number, a quantity, a letter, that divided by itself is equal to 1. So those two factors, because they're equal to 1, we can get rid of them. And now these other things just get written down for our answer. So x times the quantity x minus 2 all over x plus 5 is the simplest form of the rational expression we began with. So I'm going to box my answer. Okay, here again I'm going to factor the numerator and the denominator of this rational expression. I see a common factor of 4 in the top, the numerator, so I get 1 minus x. In the denominator here, I need something to multiply to -2 but add to 1. And I know that to be a -1 and a positive 2. So the denominator gets factored into x minus 1, x plus 2. And now I look at my numerator and my denominator, they're factored as much as they can be factored, and I see that I have a 1 minus x and an x minus 1, which are very similar to each other. So what I can do is, I can't just switch these around. I have to factor out a -1 to make that look like this. So I'm going to come over here to the side to show you. If I take out a -1, that gives me -1 plus x. And now -1 plus x is the same thing as x minus 1. And so what this becomes, I've got the -1 that I'm going to multiply with my 4 to give me -4. And now I'm going to switch this to x minus 1 all over x minus 1, x plus 2. And now I notice I have an x minus 1 and an x minus 1 that I can get rid of. And my final answer will be negative 4 over x plus 2. Okay, our last example here tonight contains a couple of special cases when we're factoring. I notice that the numerator is a difference of perfect squares, so I'm going to factor that into x plus 2, x minus 2. I notice that my denominator is a difference of cubes. Okay, and so coming over here to the side to remind you about what that looks like. Some time ago, we wrote down the formula for a difference of perfect cubes so that we could remember it and save ourselves time. Remember that a difference of cubes is equal to x minus a, and then x squared plus ax squared. Okay, and using that formula for the difference of cubes, I know that my denominator is going to factor into x minus 2 times x squared plus 2x plus 4. And now at this point, I would look at this trinomial and determine whether or not I can factor it into two factors. And I know that I cannot, because a product of 4 and a sum of 2 is not possible. So then I look at my numerator and my denominator. Is there anything in common? And I have an x minus 2 on the numerator and the denominator that I can get rid of. So that divided by that is 1, so we get rid of it. And we're left with x plus 2 over x squared plus 2x plus 4. Look at all those cheaters. Man, I hope none of y'all are cheaters. See you tomorrow.